Hey, I just wanted to show you something that I was thinking about that I thought might help you understand rates better, and it has to do with Skittles. So let's just pretend that what I have here on the screen, the little dots are little Skittles, and there are 12 Skittles. And let's say that you wanted to see how long it would take you to eat them, so you ate them. And you notice that it took you 30 seconds to eat all 12 Skittles. So we could say that that's a rate, that you can eat 12 Skittles in 30 seconds. So we could write it as a fraction, as a rate, or as a ratio. Now, if you can eat 12 Skittles in 30 seconds, how many Skittles could you eat in half that amount of time? In other words, in 15 seconds, you could probably eat half, since that's half the time, you could probably eat half the amount of Skittles. So you could probably eat about 6 Skittles. Okay? Well, that's another rate or ratio, but it's actually the same rate because you're eating Skittles in the same amount of time. You're eating 6 Skittles every 15 seconds. And then if you have another 15 seconds, you'll eat 6 more, so that'll be 12 Skittles in 30 seconds. So those are actually equivalent rates because you're not eating the Skittles any faster. It's just more time is passing, so you're eating more Skittles. Okay? So what if you had 60 seconds? Alright, well, if you can eat 12 Skittles in 30 seconds, if you have twice as much time, you should be able to eat twice as many Skittles. So you would be able to eat 24 Skittles in 60 seconds. Alright? So all of these are equivalent rates. They're describing how fast you can eat Skittles, and there's different amounts of Skittles with each different amount of time, but they all describe the same rate of speed of eating Skittles. So we call these equivalent rates because they're describing how many Skittles you can eat in a certain amount of time. And so you can always have different amounts of time, so you'd always have different amounts of Skittles that go with each different time, but you're still eating the Skittles at the same rate of speed. So that's what equivalent rates are. Now, I want to propose a problem to you. Let's just pretend that you are in your backyard and you notice that you are, or that you know someone, and they're standing in your yard, and that person is a friend of yours, and make it a girl. Okay. And you measure, and you know how tall she is, and she happens to be 4 feet tall. Alright? Now, you also notice that she has a shadow. It's on the ground, and you measure the shadow and how tall it is, and you notice that the shadow is actually 5 feet long. Okay? So you just observe that, and then you think about it, and then you happen to notice over on the other side of your yard that there is a tree. Okay? And it's a big tall tree, and you can't measure how tall it is. It's just a really tall, big tree in your yard. And so you're looking at it and you're wondering how tall it is. And you're saying, I wonder how tall that tree is. Alright, and you notice, though, that there's a shadow on the ground of the tree. And I don't have enough room to draw it like I want to, but let's just pretend that's the shadow of the tree. So you come over and you measure the shadow of the tree. And you notice that it is 20 feet long. The shadow is 20 feet long. Can you set up a proportion to figure out how tall the tree is? Alright, in other words, we want to figure out how tall the tree is. So we're going to call that X because we don't know. If you could set up a proportion to figure that out, I want you to try that and let me know what you get. Okay? Bye. See you next time.